Good. Does it move? Yes, it does. Good. So hey, I'm Mats. I work at Relax, and a little bit of my past. More than 10 years ago, I was still playing around with different things. During university, I had access to a server, which, I mean, it's a university-provided server. It has absolutely nothing for me. No access permissions or anything. Nowadays, I'm a lead developer. We are dealing with EC2 instances, Azure machines, Kubernetes things, and these huge private cloud things. So plenty of different kinds of targets for deploying software. And yeah, so why does the deployment even matter? And this picture is somewhat similar to what Brian was talking about. His was maybe more informative, but the same idea is there. So we have the people doing the coding, we have the CI/CD happening, we have things moving to server, we get the feedback from the angry users, and the loop repeats. I'm not talking about testing and project management, just actually deploying the artifact. And some of the things we might want from a deployment system is that it's scalable. I mean, you could scale to a single machine on your university host, or you could have this Kubernetes system with plenty of redundancy. It should be reliable to at least some extent, so when you're doing your Git push, you actually do end up having the artifact in your target machine or machines and running there. Hopefully there's in a way that it still works a year ahead from now. And same thing, it should be repeatable, it keeps on working. Yeah, your deployment today is the same as your deployment tomorrow, model for the code changes. No sudden changes, no configuration, unexpected configuration changes or anything. And maybe as a question at this point, what kind of delivery methods have you guys been using? This is a DevOps related meetup, so I'm sure everybody has, or most have been dealing with Kubernetes, Docker. The more old timers have probably dealt with moving the artifacts manually to servers and running them there. Some have been dealing with interpreted languages where you copy the sources there. Some have dealt with compiled languages, which bring their own issues of having the libraries in place, hopefully so that the executable can find them. And this is basically what I'm talking about here. I'm not going to go with what is best, what you should be doing. More like the experiences I've had in my longish history, and what has worked for me, what hasn't, what we might still be using somewhere, what I'm still dreading today on seeing. Yes, oh no, not double click. One of the, especially the early ways of deploying compiled artifacts is to have static binaries. And especially when dealing with Haskell, we can differentiate between having those full dynamic libraries, executables, which are both linked on the libc level as well as Haskell level. So your ASIN libraries are linked separately, and your PostgreSQL SO files are also dynamically linked. Then Haskell has support for static executables, where the actual Haskell dependencies are then compiled in. So your ASON will be part of the executable, but your PostgreSQL SO is still dynamic. And then you have your actually static binaries on the Linux level where you embed everything. Two approaches here is using the glibc method and the muscle method. glibc is the older, more venerable base library for Linux-based systems, but it's not well suited for static building. It has its issues. And Muscle is a newer one, mostly used, I guess, with Alpine Linux, and I think Go is often using Muscle for static building. So especially with Go executables, you'll see Muscle build static executables that just work everywhere. Really nice. So one way of checking this is your LDD executable, and if you have a huge list of libraries there, then it's a dynamic library. For static, good. It's scroll down my section here. For you should be able to see that it's not a the LDD is saying it cannot do anything. It's not a dynamic library. Syncthing is an actually Go-based executable which is using static building, and it works on, I'm in x86, it works on ARM, it works on my Pocketbook. They have plenty different targets that they have built it for. Building Haskell statically isn't necessarily easy. Many years ago, as in when I was in university, there was still some Stack Overflow posts on how you do your -optl, -static, and -fpic flags into your GHC command to make it actually statically built properly, and it might have worked occasionally, not always. And the situation isn't any better nowadays. I think it's even gotten worse. You do require some exotic knowledge to have static binaries built. Cabal, for example, what is this picture? Yes. Sorry, I'm skipping. So first try of trying to just SCP a dynamic library to a machine, it does not work because there are not all the libraries are present. The ELF executable expects the libraries to be in place and in certain place for it to actually work. If it doesn't, it's complaints about no such file or directory. And this method I'm showing here is basically what I did in my old university days. We had the old web server, we had single user access, we had the, I don't remember what the directory was called, but this well-known directory for where you could add your HTML files and have your own website in there. It was meant for having static sites, but it did also have CGI bin enabled. And those old timers who remember, CGI bin is basically a web server method of executing an executable which outputs, I wonder what it outputs. Is it just HTML, or does it even output some HTTP level items as well? Anyways, I built a couple of different softwares and SCP'd the file to the CGI bin directory and had my own dynamic website working. But yeah, with the dynamic things, it does not work, especially if you have a single user access. So how would one do this in Cabal with static building? And Cabal has a flag for enabling static builds. I did a simple hello world executable and just tried a couple build testers enable static executables, and the results weren't really pretty to look at. There was a couple of screenfuls of errors, linker errors, I think, elf errors, and then just failed. Even if it had succeeded, it would have most likely still been complaining about locals, and there's another thing that it usually fails with local and I think time zones. So anything using locals or time zones will fail in runtime. When I was still doing this in the CGI bin days, it also often complained about SQLite libraries or things like that, that if some method function was called, the symbol was requested, then it would fail in runtime. So not ideal knowing that you have these runtime failures if some code path is called and you are aware of them. Not that this is any better since it doesn't even allow building statically. And yeah, so it is possible to build the static binaries. It requires some exotic knowledge. Right now I wouldn't be able to do it manually using just GHC, I don't think. Maybe some simple hello world. For sure I wasn't able to do it with Cabal. And plenty of the information is literally decades old at this point. The information stack of flow post is from the times of my CGI bin days. And even then it was already a little bit of old-timer knowledge. Yeah, so as a recap, I did use the CGI bin. I did manage to get it work in the olden days. We at work, the older version of our software was built statically with older GHC version. This was way before me and Martin joined, and it did work. It worked actually really nice. We didn't have too complex of a CI/CD setup at the time, but we lost access to muscle at some point. There was no GHC build with muscle available, and we ended up doing a hack. This is where the crying comes in. We're using dynamic executables where we manually copy the library dependencies to the server beforehand to make sure that they exist there, and then the dynamic executable works. It's a hack. It feels bad. It feels bad to even think about it. Yes?
Yeah, no, just want to add to those. Not all libraries, just missing ones. Trial and error. Run it. What does it complain about? Okay, let's add it.
Pretty much.
I just want to just also add that it's more like, it's not like it never works. It's like it's a trial and error kind of game where you mostly lose. So what you do to maximize your chances is if you're deploying a Red Hat number, whatever, Linux, you're going to try and build an environment that's like a Red Hat, the same number version, so that hopefully you are going to create binaries that target the same shared libraries and copy missing ones.
Yeah, you want to have the glibc matching more or less. You want to have the libraries matching more or less, and the ones that are missing, you SCP to the server. And then you do this for a couple of hundred servers. So would you say this is reliable, scalable, and repeatable way of doing this?
I'm ashamed to say that this has been working super well.
It just means how good we are. Or lucky. So yes, so luckily there are more modern ways of doing things. Am I moving the screen? Good. So Docker. Docker is kind of the more or less de facto way of delivering artifacts nowadays, or other container-based systems. There is, I mean, the benefit is that they embed the libraries in there. You have your full system within the Docker container, and everything is where it should be. It's repeatable. You have the single image you can copy anywhere that you have the Docker daemon running, and it should be just running. No further effort required. And there's a really, as Brian already mentioned Stack, or was it Martin who mentioned Stack? And this is a really, I spent like 5 minutes on figuring this one out. This isn't perfect, but this works. Docker file for building a hello world executable, just stack build, stack run. It works. And I mean, I could copy this to Kubernetes and have it running, copy it to AWS, have it running, copy it to Azure, have it running. It's fine. Yes. Then more on the functional side, we in our team are not only Haskell developers, we also have other technologies we are interested in. And I see Martin already laughing. There are can Martin guess what is the topic of my next slide? So the next topic is the Ansible derivations. Are you aware what is Nix? Who has dealt with Nix previously? So a little more than half, I think. Quick estimation. Nix is a language. Nix is a package manager. Nix is a package ecosystem. Do I have a feeling it should also have a fourth one? Well, that's Nixos then already. It basically it is a functional language, lazy functional language, like Haskell, without types, unlike Haskell, that is used to build these derivations that define what some artifact is. The artifact can be a binary. The artifact can be a binary plus configuration. The artifact can be a JSON string. It can be just plain string. The interesting thing is that it will automatically collect the dependencies within the derivation in a tree-like structure. And if you are referring to a derivation of any of these, it will also bring the dependencies with them. Nix has a good binary caching system, so you could build this Haskell executable with Nix, then push the derivation to a binary cache, which would also push all the dependencies in there. And you could then, on your target server, on any target server that has Nix enabled, you could fetch the same artifact from the binary cache and have all the dependencies taken from there as well. So this is also a really reliable method of delivering artifact, not only Haskell, but any language, I think, or any package, any service, maybe even. So you can see here Nix build, Nix run, and you get your results. I could do this on my on any of the servers I have that have Nix enabled. And as an example of the dependencies it's gathering, in this case I didn't do any extra stuff in there, so it's it has a bit of dependencies there. It is actually collecting GCC in there as well, and some of the other stuff. But this could be simplified even further to make the derivation smaller. But you can introspect what it does. And I mean, not every server, Nix isn't that ubiquitous as Docker daemon, for example. So it might be a little bit of a hassle to have Nix installed on your servers. It might even be, in some cases, a security concern of having a full Nixos machine, for example. It doesn't have all the ISO certifications or whatever you might need if your company is really security conscious. But you could still have the best of two worlds. You can go with Docker images again. The difference is that in this case, in this time, it's more repeatable. In the previous example, how far is my previous example? This does not define any, this isn't the best example, but often you see Docker images which have these upget, update, upgrades as a prefix, which updates the package manager state to the latest one every time you are building the Docker image. Meaning that the dependencies change behind the scene for every build. In our case, this one, the dependencies are defined by a top-level Nix packages version. And unless you change that, your one build is indistinguishable from the second build. You can run this how many times and you will still get the same result. Modulo, of course, if there's some compiler which records a timestamp in the executable at which point the hashes don't match, but Nix doesn't care about it. It will still get the same output hash. And I mean, this is also a nice declarative way of defining an image. This isn't a step of executions or a list of executions. This is declaring what we have. This is declaring that we have some image with a name, version, and that it's running our executable. I'm actually going to ask you, Martin, help. What is the tar.gz called that this creates? It has a name, the one that you can load to Docker. Anyways, it creates a tar.gz file that you can load to Docker, and then it's a normal Docker executable. And you can see, can you see? Yes, that it's only 43 megabytes. So it's also minimizing the dependencies, minimizing the package size. If this had required any configuration, I could have added to the same thing as well. Then the final step, I showed the issue, the GitHub issue. How far back? The fully static Haskell executables. It's still green, it's still open. This is, does it show? Opened on 2018. That makes 5 years ago. Was it July? Yes, a little over 5 years ago. It's still open, it hasn't been resolved. Even the fully static executables, I think even that is still statically building only 93% of package. and the rest can't be built, period. Luckily, Nix packages nowadays have a set of static has a set, oh, that's too wide. Has a set of statically built packages. So using this derivation here, using the packages static, overriding that Haskell packages that's within the packages static, I can get muscle statically built executable, the one that I failed to build with Cabal a few slides earlier. This will take a while to compile. This isn't part of the binary caches. I don't think, at least. But it does work. I tried building Pandoc, I think. I got tired of waiting after half an hour. But it does work. I think at least Postgres is built in this way as a static executable. Yeah?
Is there some scrolling around?
Yes, I can scroll it, but I need to turn my head. I need to do this control with my back to the laptop and see, easy to read Nix code. After 3 years of experience reading it. And it does work. I can build it. It's a static executable. It runs. It works. At least this simple hello world example. I was unable to get this to work with just plain old Cabal. Yes?
Is this one using glibc?
No. Muscle.
Where is muscle mentioned?
It's mentioned in the build logs, at least.
No, I mean, like, at what part did you specify that you were going to use muscle rather than glibc?
It's not explicit here. Sorry, wrong screen. This one. No. This one. So let me scroll to the.
Just static executable?
It's this section here. So there's this packages static, and there's also separate, I think, packages muscle, which I don't know what the difference is. This was the first one that I tried. Yes?
I think the difference is that packages static uses muscle and static builds, whereas packages muscle just uses muscle with dynamic builds.
Yeah, could be. More questions? I was actually at my last slide there.
So it's time for questions. Okay.
Yes.
We still have 5 minutes for questions. So we didn't go in the order where the title was, right? It was like
No.
what works, what doesn't, what makes you cry. And now
No,
we're at the end. This is
No, I wasn't able to make GPT make title that also maintains the ordering.
You cry now.
No, but it did kind of go. Actually, what was the title? The crying happens at the front, at the first, because of all the static building with all the decades-old Stack Overflow posts.
So instead of being a negative spin on the title, it's actually a positive spin on the title.
Sure.
What makes you cry, what doesn't work, and what works.
Yeah.
So what would you recommend then to run today?
To be honest, I don't want to be recommending anything because there are different scenarios. You need different techniques. I wouldn't necessarily use the static builds to deploy a service to run on hundreds of servers. I could see having a GitHub pipeline, creating an artifact for people to download that is statically built. I wouldn't necessarily do the tar.gc, that's Docker image, and have that in GitHub, for example, GitHub releases. Yes?
So back to the Nix loves Docker side. How strong is the the Nix tooling with Docker, like if you run the build, next slide. If you run so if you run Nix build and you get the result file, is it byte for byte the same if you run the same command 2 times?
No. It can be, but no. So different compilers have different ways of compiling. Some literally attach a timestamp in there, meaning that it's no longer a byte by byte similar, or some other random value in there. This is making, for example, the content addressable storage in Nix a little bit difficult, because you don't necessarily always get the same output for the same input. But what Nix does, it doesn't really care about the output, it cares about the input. So as long as the input doesn't change, so my sources don't change and I'm not changing the previous file, the Nix will detect that there's no changes and will just reuse the same computation.
So it's cached?
Yes. Yes?
Yeah, so another way to answer the same thing is that, well, if you rerun this, will this be byte for byte the same? And the answer is yes, you just pull the cache. Another way to explain it is that, yes, if you wipe your cache, rerun it, you might have differences, but it's also good to notice that Nix does a lot of effort to neutralize all of the sources of, let's say, uninteresting byte changes, such as timestamp, such as writing or reading from the local disk at other places than the place you're building from. What's the weather in Moscow? I don't know, like, this gets like, Nix isolates as much as possible so that when you rerun it, the only sources of change are the shady ones that you don't want.
So it does do a lot of effort on that. It's not perfect, but it's still better than most. And that's the reason why you will see, if I had done a Docker PS for this, for example, Docker list images?
Docker what?
Docker list images. It will show that the image has been built on sometime on 1970.
Yeah.
And there are other toolings and projects that try to do byte for byte reproducibility. I think reproducible builds, that at least has Debian trying really hard, and some other companies.
For decades.
If you compare that effort with Nix, I would describe Nix as pragmatic reproducibility, not die-hard reproducibility.
But like mentioned, there is also attempts by Tweak, I think, for the content addressable storage. And that effort has been ongoing for a while. It's not yet production quality.
Right? Any final questions from us? No need. Time to close then. Thank you all for joining. Thank you for Mats for the last minute talk that actually went really well. So
Yeah, literally last minute.